Okay, guys, good day to all of you. So, as I promised, this is the second part of the science paper 2023 English medium paper discussion. So, without any further ado, let's get started. So, we did up to 10th question in the first part. You can see that first part in the description as well. At the end of this video, you can go to the first part and find for it. So, let's start with the question number 11, right? So here they have given some symptoms of an illness. So you have to diagnose what is the illness, right? Following symptoms are seen in persons suffering from a disease in the respiratory system. So in your syllabus, you are doing 6 systems: digestive, respiratory, excretion. Likewise, you are doing 6 systems there. So every system includes some illnesses at the end. So you have to be familiar with the symptoms there. So look at the symptoms and let's try to select the correct answer. So first, release of blood with cough. Yes, when you have a high cough, you will release some blood when you are coughing, right? So for example, the answers given here are pneumonia, right? Bronchitis, tuberculosis and silicosis. Yes, so tuberculosis is caused by the tuberculosis bacteria. In Sinhala, we call it Ksharoga. So this is tuberculosis. When you have high tuberculosis, yes, in tuberculosis, you cough exclusively, right? Very much. Then you will get damage to your alveoles and also bronchioles, right? So you will cough with some blood. Those parts, damaged parts, will come out with the blood, right? And in silicosis also, that is due to the silica dust, and you will get some damages. That's correct, right? So we can depend on these two. And also in bronchitis, in extreme bronchitis, you can get some blood with the cough as well. Let's go to the second symptoms and try to select the most correct one. In pneumonia, you don't have much blood coming out from the cough, right? It's a kind of common cold related disease. And the second symptom is loss in body weight. Yes, when you cough much and much, yes, you will lose your body weight. So I get the feeling that this is about tuberculosis. Yes, you will definitely see a loss in body weight when you cough more and more, right? So in silicosis, you don't cough much, right? So but in tuberculosis, yes, frequent coughing is very conspicuous. You will get tired, right? High fatigue. Yes, they are talking about the tuberculosis, right? So the answer of this question number 11 is the tuberculosis. This is actually a direct answer question, right? You should know the symptoms. You can get those symptoms from the textbook or your notebook, and you have to guess whether the correct illness is pneumonia or bronchitis or tuberculosis or silicosis. So there is one more thing in the textbook, asbestosis, due to the asbestos dust, right? But here, the release of blood with cough, loss in body weight, yes, high fatigue, you will get tired more when you're coughing, yes, that these are due to the tuberculosis illness, right? So the answer is very straightforward answer. It should be tuberculosis, right? Let's move into the third one. So right, this is we have to discuss this thoroughly, right? So the question number 12 and 13 is based on this picture. This is actually an electrochemical cell. This is not electrolysis. This is electrochemical cell, which means you do a chemical reaction and you are trying to make electricity, right? So yes, you can select 2 electrodes. Here they have selected zinc and copper. And when you're dealing with these kinds of questions, you have to relate it with the reactivity series. So in here, I have given you the reactivity series. And in your exam, you have to thoroughly remember the reactivity series to answer these types of questions. So let's take the question number 12. In the direction shown by the arrow, yes, look at the top, right? You have an arrow here. This is the connection between the zinc and copper electrodes. Which of the following flows in the external circuit, right? So let's see the answer first, right? So let's start from the beginning, right? So here you have to select the oxidizing electrode and also the reducing electrode here, right? So how do you select that? To select that, you have to get the help from the reactivity series, right? So what are the 2 electrodes or the metals selected here? One of them is the zinc and the other one is the copper, right? So who oxidizes here, which means who releases all electrons? Oxidizing means, the definition of oxidizing means that electrode is releasing electrons, right? So to release electrons, it should oxidize, which means if you look at the reactivity series, the selected electrode should be in upper area, right? So when you compare zinc and copper here you have zinc, here you have copper, right? So the most oxidizing metal should be the oxidizing electrode here, right? So from the zinc and copper, zinc will get oxidized and the other one, the copper, will get reduced, right? So reducing means they are gaining electrons. Zinc will release electrons, and the copper on the other hand, they will take the electrons actually released by the zinc, right? So remember that just take the two electrodes. How you select the oxidizing and reducing agents? So you take the electrodes and look at the position of the reactivity series. The one is located above, on top is the oxidizing electrode, and the below one is the reducing electrode. So here zinc is the oxidizing electrode and copper is the reducing electrode, right? So now you may have heard the names of anode and cathode. So what are anode and cathode, right? So the oxidizing species will be the anode here, right? The reducing species will be the cathode here. So if you take here the zinc and copper, this is the anode and this is the cathode, right? This is the anode, zinc is the anode, copper is the cathode, right? So, and also you have to select the positive, and in a electrochemical cell, or in a cell usually you have two terminals, positive and negative terminals. So what is the negative terminal here, what is the positive terminal here, right? So before we go to that, so let's write the half reactions from the zinc and copper, right? So let me take the zinc, right? Zinc is the oxidizing species. Usually zinc is in solid state in the electrode, and oxidizing means the zinc is releasing electrons. So he can release two electrons and will be oxidized to zinc 2+, right? So this is the oxidation reaction, or the anode reaction. So in the anode reaction, you can see they are releasing electrons. The electrons are negatively charged, right? So if you want to select the negative negative terminal, so now since electrons are negatively charged, zinc should be the negative terminal here, and yes, the opposite one, copper, should be the positive terminal here. That is the place where you have the reduction, right? So now I think you have got the theories covered. So now they are talking about the current, right? Current. So what do you mean by an electrical current? Electrical current is flow of electrons, right? You will have the current to the opposite side of the flow of electrons. So usually in this negative terminal, which is the zinc electrode, it is having access of electrons. So what happens here is the electrons here will flow towards the copper electrodes, right? So electrons will flow in this direction, the marked direction, right? You can see that here, to this direction, from zinc to copper, right? So the standard direction of the current is the opposite of the flow of electrons. When you have the electron flow from zinc to copper, the current will flow from copper to zinc. Just remember that. So the answer for the first one, in the direction shown by the arrow, which of the following flows in the external current, right? So I told you the zinc electrode is in access electron state, then these access electrons will flow towards the copper, which means this marked direction will be the direction of flow of electrons. Second one should be the answer. So now here they are asking about the cathodic reaction taking place in the above cell. So what is the cathodic reaction here? Reaction is the reduction reaction. So reduction means the species will gain electrons from source, right? So here, even though the reductive electrode is the copper, you don't see reduction in copper species, right? So instead of reduction in copper species, what happens here is the reduction of hydrogen ions. So you can see that in the solution you have dilute sulfuric acid, right? So sulfuric acid, in a solution of sulfuric acid, sulfuric means H2SO4, right? And it will give you, in the solution, it will give you H pluses and SO4, 2 minuses, right? So you will get 2 H pluses here when you balance these equations. So however, this H plus in the solution will get reduced, right? So which means H plus will get electrons, right? Electrons to give out hydrogen gas, right? You will see that hydrogen gas is evolving, right? And when you balance this equation, you have two hydrogens in the right hand side, which means you have to put 2 H pluses here. 2 H pluses will gain 2 electrons. So this is the balance equation, I mean the reductive equation, and on the another name we can say it as what, cathodic reaction, right? So the third one should be the answer here, right? So you should know these theories. I will upload the theories of these electrochemical cells and electrolysis in my channel. So if you think these are very important for you, just subscribe my channel and stay with me, right? Let's move to the 14th question. So now this is very easy. When we are discussing the first part, we talk about the frequency of light changes during the refraction also. Let's see. Consider the following statement regarding the refraction of light. So the statement A says light refract only when it travels from rare medium to denser medium. That is not, right? That is incorrect, right? It can refract when the light beam travels from dense to rare medium also. Other way around is also correct, right? So this statement is incorrect. So when you definitely know the statement A is incorrect, you can straight away cut off some answers from here. Look here, the A one cannot be the answer. The third one, the first one cannot be the answer because A is incorrect. They are talking about the true statements. So third one is incorrect, right? So now we have only two answers to depend, right? So we have 50-50 chance of getting correct answer and also the wrong answer. However, let's see the other statements also. Reason for refraction is the difference in the speed of light in the two medium. Yes, right? Due to the densities, due to the speed difference, those are the reasons for having refractions, right? Different refractions or deviation of the path, right? So this statement, the second statement is correct. So the C, frequency of light changes during the refraction. No, right? I told you in the first video also, this cannot happen, right? The frequency is from the source, right? It will not change. The lambda will change. I mean, the wavelength will change. The speed will change accordingly, but the frequency will be constant. So the third or the C statement is also incorrect. So you can cut off this fourth one. The answer is only B, right? Moving into the question number 15. The acceleration due to the gravity on the Earth is 10 ms2 minus. We know that this is the gravitational pull. On the moon, its value is 1/6 of the value on the Earth, right? That's correct, which means the gravitational acceleration in the Earth is 10, and in the moon it's 1/6 of the Earth, right? So which means 10 times 1/6, the value on the Earth. What is the weight on an object on the moon if it weighs 60 Newton on the Earth? So you have to understand that when you go from Earth to moon, your weight decreases, not the mass, right? Mass means the amount of matter present in an object in your body, right? You are not losing your mass, but the weight is related with the gravitational acceleration. So if the gravitational acceleration changes, which means the weight will change. So how do you convert masses into, right? Masses into weight. You take the mass, right? And multiply it by the gravitational acceleration, let's say g, right? So acceleration is usually denoted by simple a, but the gravitational acceleration is g, right? That is where you can get F equals mg, or the weight equals mass times the gravitational acceleration. Weight is equals mass times g, right? M times g, mg, right? So however, they say if you have a weight of 60 newtons in the Earth, right? So they're asking you to calculate the weight on the mass. So in the first part of this sentence, they say the acceleration due to gravity on the Earth 10, and on the moon it's about 1/6. The gravitational acceleration decreases in a fraction of 1/6, which means, just understand, the weight also decreases from the same amount, right? So if you get the weight as 60 newtons, right? So you can get the weight on the moon by multiplying it by 1/6, right? So which means, if you simplify this, the answer will be 10 newtons, right? So the answer is 10. First one is the answer, right? Moving into the sixth question. So they are talking about the animal classification here. So you know that we have two types of animals, invertebrates and vertebrates, right? 5 invertebrate groups and also 5 vertebrate groups. So here they are talking about aves and mammals. Those are vertebrate groups. So I have here included the 5 vertebrate groups here. First the fishes, pisces, and then you have amphibians. And amphibians are, frogs and all, right? They stay in water and also in terrestrial environments. And the reptiles, aves and mammalians, that is us, right? So now the first one of the following, the 16th one of the following characters, what are the characteristics common only to aves and mammals belongs to the vertebrate animal groups, right? They are only confined to aves and mammals. They're not talking about anyone else, right? So let's look at the answers. First one, warm-blooded, right? And yes, A is the warm-blooded. Yes, when you take the 5 vertebrate groups, there are 2 groups based on the temperature controlling of their body, right? So those are warm-blooded animals and cold-blooded animals. So if I give you a short note here, the first 3 groups are known as cold-blooded animals, right? Cold-blooded animals, right? And the 4th and the 5th group, the last 2 groups are known as warm-blooded animals, right? And you have very scientific names. You have some scientific names for these things, right? So the cold-blooded animals are known as poikilotherms. I have here mentioned that, right? Poikilotherms. And the warm-blooded animals are known as homeotherms, right? Homeotherm, right? So let's try to understand what are poikilotherms and homeotherms, are cold-blooded and warm-blooded, right? So pisces, amphibians, reptiles they are known as cold-blooded animals, which means they will change their body temperature according to the environmental temperature, right? So look at this graph here I have here included. In the x-axis you have the environmental temperature. From left to the right, the environmental temperature increases, right? In this y-axis you have the body temperature. So this graph, right, this line, this straight line belongs to the poikilotherms, or the cold blooded, which means when the environment temperature increases, they increases their body temperature as well, right? So, and on the other hand also, when the environmental temperature decreases, they decreases their body temperature. So this is actually a primitive feature, not advanced one. It is somewhat very disadvantage for these animals. So however, that is the meaning of cold-blooded animals. Examples: pisces, fishes, amphibians and reptiles. And the most advanced feature is the homeothermic, or the warm-blooded animals, which means they will keep their body temperature in a constant value, independent of the environmental temperature, right? Which means simply they will not change their body temperature even the environmental temperature changes, right? So they will keep that body temperature. Look here, right, this dotted line, they will keep their body temperature. For example, we have around 36.9 Celsius, which means 37. We will try to keep 37 as it is. We are not going to change whether the environment got cold or hot, right? So we are homeotherms, or warm-blooded, right? So you have two groups, vertebrate groups, aves and mammals, right? So this is the statement A belongs to both of them. B, skin covered with hair, that is only belongs to mammal, right? Mammals, they do have a very specific feature in their skin. They have body hair, right? So this is only belongs to mammals, not for the aves. See, bony internal skeletons, yes, but this bony internal skeleton belongs to everyone here. They are only confined to aves and mammals, no pisces, amphibians, reptiles, aves, mammals. They all do have bony internal skeletons, right? So you don't have 3 selected answers here, right? So you can avoid this C as well. Then D should be correct. 4-chambered heart, yes, aves and mammalians, they have 4-chambered heart, right? Our heart is divided into 4 chambers, right? So D is correct. The correct answer for the 16 is A and D, right? Let's move to the 17th one. These are direct answer questions. Which of the following is false about metals? First one, majority of the elements are metals. Yes, you have about 120 elements in the periodic table. Out of them, most of them are metals, right? Yeah, that's correct. They're asking about the false statement. All metals conduct electricity. Yes, from your childhood you are learning one of the key features in metals is that they are conducting electricity, right? So this is correct. Even you have the whole word there. Yes, they do conduct electricity. Third one, metal ions loses electrons and form positive ions. Yes, metals do oxidize, which means they release electrons from their outer shells. For example, if you take sodium is a good metal, right? The electronic configuration of the sodium is in the 11th position, which means they have 11 protons, right? 11 protons, and you have 11 electrons as well if the sodium is neutral. So which means you can fill the shells as 2, 8, 1, right? That is how you get 11 electrons here. So in the outer shell they have only 1 electrons. So usually they are making positive ions, negative ions to get stabilized, which means to fill up their last shell, right? I hope you remember the octet rule. They have to somehow, if they want to get stabilized, they have to somehow fill the last shell, right? So they have 2 methods to fill. Either they can take 7 electrons, or they can just remove out these 1 electrons, right? So usually they do the most easiest thing, right? So rather than getting 7 electrons from outside, it will be easy to remove out 1 electrons at the last shell, right? So if sodium release this last one, he will only have 10 electrons now, right? So but protons will not go out, so which means you have 11 positive ions and 10 negative ions now. So the sodium have 1 positive ion access. Usually metals do this. So the third one is also correct, right? So fourth one should be the false one. All metals react with acid and liberate hydrogen. Not all metals, right? So when you look at the reactivity series, the metals underneath the hydrogen, they will not react with the acids and they will not liberate hydrogen, right? But metals above the hydrogen, they will react in different speed. They will react with the particular acids and liberate hydrogen, right? So this statement 4 is not correct for all metals, right? So the answer should be fourth one. Let's move to the next question. Question is about acids and bases and the indicators, right? So in your syllabus you have different indicators like methyl orange, phenolphthalein and litmus also. This question number 18 is asking about the methyl orange here, but however I have included the phenolphthalein, right? The color change in the acidic and basic medium of phenolphthalein. And let's talk about the methyl orange here. So the methyl orange in acidic medium, they will give you the red color, and in the basic medium they will give you the yellow color, right? So before that, let's try to understand the pH scale here. So pH is starting from 1 and ending will be end at 14, and in the middle you have 7, right? So 1 to 6, right? 1 to 6 here will be the acidic range, and 8 to 14 here, right? 8 to 14 here will be the basic or alkaline range, right? This 7 at the middle is the neutral end, right? So when you go towards the left side, more stronger the acidic nature, and also when you go to the right side, you will get high basics value, right? So now when a few drops of, look at the question now, when a few drops of methyl orange were added to the certain solution, it turns red. Which of the following turns red? Okay, right. So look at this graph and just try to select the answer. If you see, if it is red, they are talking about the acidity range. Usual pH color range of the methyl orange is 3 to 5, right? So the practical readings can be slightly differ from the standards. That's okay. But if you are getting red, which means they are talking about the acidic range, right? So look at the numbers given here. In the first one you have 2, which is the acidic range, and second one 7, that is neutral, right? In neutral you won't get red color. 12 and 14 basic, you should get yellow, but here the red color is the observation. Definitely you can stick with the first answer because this is the only acidic value given here, right? Let's move to the question number 19 now. Let's read the question. 19. If it takes 4 seconds for an ultrasonic wave sent by the ship to the bottom of the sea to be reflected and come back to the ship, it takes 4 seconds, right? 4 seconds to the ship. If the depth to the bottom of the sea is this much, 2,880 meters, what is the speed of the ultrasonic wave in the seawater, right? So you can roughly remember these numbers, right? Speed of the sound in the air is about 340, 330 meters per second, and in water it's around 1,500, and in solids it's around 5,000, right? So you can just remember these numbers also, and I can guess the answer is should be closer to the 1,500. Let's see, but you have to somehow calculate this one, right? And now let's try to understand the concept here. So let's say this is the waterline, and above that you have a ship, right? And in the ship you have an equipment called sonar equipment. It releases some ultrasonic waves, and that sonar equipment is able to get the depth of the sea, right? Depth of the sea, right? You know, for the sailors, to the captains of the ships, it is very compulsive to get the depth, right? So how it works? So in the sonar equipment, they release the equipment releases ultrasound waves. So according to this statement, they say it takes 4 seconds, which means the sound wave will go towards the bottom and it will come back to the sonar equipment, right? For this process, it will take 4 seconds to reach again to the sonar equipment, the ultrasonic wave, right? So, and they have given the depth as 2,880 meters, right? The depth means from sea level to bottom depth, right? But here in the first part of the para, they say it takes 4 seconds to reach the bottom and come back, right? So just understand the depth means only one way, not going back and also coming back, right? It's only going towards the bottom, right? So this to go towards the bottom, it takes only 2 seconds. Right? So to come back, to go bottom and to come back, it takes 4 seconds. But depth means from the sea level to bottom, right? So usually the ultrasonic wave, it only takes 2 seconds to reach the bottom, right? So now how to calculate? They are asking what is the speed of the ultrasonic wave in the sea, right? So now here, right? So what is the equation to calculate the speed here, right? So speed equals the total distance divided by the time. So distance, they have given the depth here 2,880 meters, and the time taken for it is not 4, right? It will be tricky. Just try to understand. The depth is only 2 seconds, right? So you have to divide this by 2 seconds, right? So now straight away you can cut off 1,440. Then this s goes up to the numerator, and your answer should be 1,440 ms minus 1, right? Ms minus 1. So the answer is second one. Our rough guess is correct, right? So the last question for this video, given below are some properties of gases, right? So let's look at the properties, and let's try to get the correct answer. Can be burnt easily. Okay, burning gas, right? Usually we need oxygen to burn, right? So we can stick with oxygen, and also hydrogen is also burning gas, but not carbon dioxide, not nitrogen. You can straight away cut off second one and fourth one. So in the second point, there's a density is less than that of air, right? So oxygen, usually we can find oxygen in close to the ground, right? That is because all the animals, plants, I mean the living organisms are living in the ground, no? So oxygen should be in the downwards region or the lower elevations, right? So oxygen is somewhat heavy, right? And or heavy or high dense. Then hydrogen is less dense. Yes, you cannot find much hydrogen. You can find, but not much closer to the ground level. But when you go up, yes, you will find hydrogen here. So yes, you can now say it should be hydrogen. Slightly soluble in water. Yes, straight away the oxygen is very soluble in water. That is why the aquatic organisms, animals and plants, they need oxygen, no? So oxygen should be well dissolved in the water, right? So you can cut off the oxygen answer as well. So can be burned easily. Yes, hydrogen will be hydrocene. That is a fuel used for rockets, right? And density is very less. Yes, you can find hydrogen in higher elevations. When you talk about oxygen, when you go higher elevations, oxygen concentration decreases. That is why the hikers, when you're hiking mountains like Everest, right? So the hikers, they take oxygen tanks because you will be lacking out of oxygen when you go up and up in higher elevations, right? So now slightly soluble, yes, hydrogen is slightly soluble in the water. So answer should be the first one, right? So that is the end of the second part. I will be meeting you again in the third part. That will cover up the next 10 questions of the 23rd paper. See you there.